Right, good afternoon, ladies and gentlemen. Just first, an interesting story relating to the hospital beds. When I was in Turkey 2 years ago, in this one city, there was a office building, and right next to it there was a hospital. So the people were moving office from that office building to another office building using the beds from the hospital. So I'm sure that we really need standards in terms of beds in hospitals. Okay, any case. Where's this? There we go. All right, cities are complex. Developers provide stock of housing and floor space for businesses. They maximize profit through return on investment calculations. And then you have government that provides mass transit networks and road networks. You also have households that choose where to live and work and how they move between these places. And then you also have government again that controls the physical development of our cities by virtue of rights associated to land. And these are all interrelated pieces of a system that actually function together. So just something interesting, I was chatting to one of my friends in France last night. No, I was not in France, she's in France studying there at the University of Grenoble. And she told me that they have about 60,000 students there. And it's just interesting, for a small place of about 7 square miles, they have 60,000 students coming in and out there every single day. And now compare this to something like New York. And we touched on this earlier in one of the other speeches as well. All the planning that goes in behind these spaces differ. There are also some of them that overlap, obviously, but they are unique. So this is why I call cities complex. It's a complex system that emerges from a collection of interacting objects, each of which experiences feedback, and they can also adapt their strategies based on the feedback. So in this talk, I'll be going over the decision makers that you find in an urban system, but I'll be concentrating on your private sector and your public sector, or more specifically on your households and government. Then I'll be talking about the modeling paradigm. How do we translate this into simulation models and the need for simulation models? And then I'll be touching on some of the results. And I'll only be touching on one specific measure of accessibility. So households have different choices that they make each and every day, or over longer periods as well. The zoning of your land determines the type of activities that can take place. So if you have, for instance, a residential area, you most likely find homes there, or a home activity, as I would call it. If you have a commercial area, you would most probably find work activities there. And these activities are separated by space. So to overcome this separation, you obviously need transport. So some of the decisions that households have to make include where they live, where they work, and which mode of transport to use. And obviously, your household characteristics also influence the choices that you make, or sometimes they limit your choices that you have. For instance, car ownership is dependent on your level of income. Then, on the other hand, you have government that needs to provide infrastructure. And here I want to distinguish between two different types of infrastructure. On the one hand, you have your economic infrastructure, which I call your transport infrastructure and your energy systems, for instance. And these are all aimed at trying to enhance the economic competitiveness of a city or a country. And then on the other hand, you have social infrastructure, which is your basic needs: access to water, access to health services, and nowadays also access to internet. So then you also have your grants and subsidies. And on this side, again, it's all aimed at enhancing the social well-being of your citizens without necessarily expecting a return on investment. And then you also have policy evaluations on the side of government. So certain policies or scenarios are developed to overcome some of the issues that we find in our cities. If we look at one of these examples, for instance, urban growth boundaries. Urban growth boundaries are often implemented to prevent urban sprawl. So that is, they want to limit expansion of the city with low density land use. Here we go. If we then look at some of the other strategies that they follow, such as higher density mixed use zoning, and couple this with transit-oriented development, you would typically find that they try to develop spaces such as to maximize or enhance public transport ridership. And then if you take an example of such a case, for instance, in the city of Johannesburg, you have your corridors of freedom. And I quote, "These corridors would have an effective and affordable public transport system and nodes, enabling residents to travel only short distances between home and work, and where all residents will have equal access and prosperity." Now that sounds very good, but how do we actually know whether these policies will achieve these outcomes? And how can we test some of these scenarios or come up with better scenarios that might achieve some of these outcomes? We can't just merely implement infrastructure or invest in infrastructure necessarily without knowing what the outcomes would be. And that is then where I would suggest modeling and simulation. So how do we then translate these scenarios into the modeling environment? On the one side, you have your real world, which is reality. It's what you perceive, and it's what happens every single day out there. And on the other side, you have your model world. So that is where you translate the reality into a simulation model. Now, I'm sure you would agree with me that your background would influence your perception of reality. If you grew up in a lower income household, your perception of reality would look much different to someone with a higher income household. And these perceptions influence ultimately how you also develop your models. And that's why it's very important to not be biased when you create simulation models. So what typically happens is scenarios are developed, and we develop these scenarios with the aim of achieving a certain goal. We then encode this into a simulation model. We run the model using certain software packages, which I'll touch on just now, and then we analyze the results to see the effectiveness. And this is then a feedback loop with multiple iterations. So in our model, we use the UrbanSim package, which is a state-of-the-art platform to simulate real estate markets and also to evaluate different land use and transport policies. And then we coupled it with OpenTrip Planner, which is also an open source public transport itinerary planner. So in the modeling world, you typically have your two paradigms. You have your transport modelers and you have your urban modelers. And on the one side of the fence, you have your transport modelers that sit there and they somehow get hold of household forecasts. They run their transport models and they try to optimize the transport network with some objective in mind. So whether that is to optimize the flow through an intersection or to reduce total travel time on the road network, they have a certain objective that they're trying to achieve. And then on the other side of the fence, not the fence, you have your urban modelers, and they somehow get hold of your travel time forecast. They run all their models with urban growth simulations, and they try to determine what is the service requirements in a certain area, as well as trying to evaluate certain policies with respect to land use. And then sometimes, if you're very, very lucky, you get interaction between these two models, iteration per iteration. But the problem then is that you sit with very, very long run times, and these can be typically a few days up to weeks. So it brings us to a very difficult situation. On the one hand, you can argue that there were first settlements, and to move between the two places or between certain places, you needed to develop roads. On the other hand, you can argue that you were traveling long distances perhaps, and then you had to develop a place to stay. So which should be prioritized, transport or urban? And well, my answer to that is none. We should try to integrate these. Transport models should speak to urban models, and urban models should speak back to transport models. So just a high-level overview of our modeling procedure. We do a lot of GIS data preparation. We also run the OpenTrip Planner software package, and these data then get fed to UrbanSim. UrbanSim runs over a time period. We first calibrate it on a 10-year period in the past, then we run it 30 years into the future to forecast urban growth. And then we get outputs that we analyze further to determine certain parameters. If we take a closer look at OpenTripPlanner, what you need or what you require to run OpenTripPlanner is a road network, and we source this from OpenStreetMap. We then also give it the GTFS files, which stands for General Transit Feed Specification. It's a standard developed by Google in which you can just publish your public transit itineraries. And how most transport models then work is to calculate a shortest path route. Okay, wait, let's first touch on this. We run the graph builder in OpenTripPlanner and obtain a graph or a network. Okay, so how most transport models then work is, on this graph or network, they try to determine the shortest path between 2 points or between origins and destinations, but based on travel time. And we argue that we have very unique circumstances in South Africa, and we cannot necessarily use travel time as a predictor because we are all equal. No. We make a case for cost-based transport. Okay, 85% of households earn less than 9,500 Rand a month. 20% of these households walk to work, and 40% rely on public transport, and they spend a very disproportionate amount of their income on public transport. So we argue that these people are more sensitive to the monetary cost than travel time. If you live in a very low income household, you will much rather get up earlier and get to work earlier or travel longer times than pay more because you can't really afford it to get to work quicker. So we then adapt OpenTripPlanner to work out costs between origins and destinations for us, and then we feed this to UrbanSim. Okay, UrbanSim is based on discrete choice theory, so it simulates the choices made by various agents in your system. For example, the probability of a household choosing a specific, or a household agent choosing to buy a specific house. We also have 5 submodels that then run and have different behavior for different income groups. And then it takes as input, amongst others, these lowest cost trips that were obtained from OpenTripPlanner. Okay, so if we go into the results, and I'm going to look only at accessibility to jobs. Here you can see a map then that shows the accessibility to jobs in the region. This is the city of Tshwane, by using only private vehicles, and we limited the cost of transport to 40 Rand per day. So the red zones are very high accessibility to jobs, and the green zones are very low accessibility to jobs. So now, for instance, if we introduce public transport networks, we see that there's a high increase of accessibility to jobs. And these are typically where your public transport networks also operate. So you can clearly see that there's a benefit to have public transport. And as I mentioned, this is just one measure that I'm touching on, but I'll speak about the usefulness of it just now. So putting this all into perspective, we want more sustainable cities. But what makes a city sustainable? Well, it's reducing the carbon footprint and it's reducing urban sprawl. And common causes of sprawl is typically single-use zoning, your low land use densities, and, for instance, fast food chains, which all promote car dependency. Ultimately, we need evidence-based decision-making, and I think that's where the usefulness of a model like this comes in. If you want to evaluate different scenarios or different policies, then a model like this would enable you to do things like that. And ultimately, we want to develop all-inclusive, sustainable cities. Thank you.